F, solve the inhomogeneous difference equation. Now the other ones were like 0, they didn't have anything on the other side. In this case, you'll see there's like 144 on the other side. Okay, and this is considered a constant. Okay, so the technique for this is, because this is a constant, it's not a linear. Linear would be am plus b. If there was a quadratic equation over the other side, something like this, then you'd be doing something like am squared plus bn plus c. But we can see that we only have just one number, 144, yeah? In a case like this, what you do is you replace all the UNs. You just say UN equals A, which means it doesn't change, which means UN plus 1 is also A, and UN plus 2 is also A, because it isn't changing. It's a constant. Any UN value is A. So this is the technique for it, okay? So you go through your initial phase, you go A minus 2A minus 35A equals 144. And then you go, okay, what is that then? That's, I think it's minus 38. Is it minus 38? Yes, minus 36, thanks. One month's a plus. Minus 36A is 144. Then you divide by minus 36, you get A equals minus 4. Okay? So, what to say is, particular solution, UN equals minus 4. Okay, then you just park that off to the side. That's done. You come back at it again, except this time you're striking off the 144 is 0. And you go back to what we did in the previous exercise. What did we do in the previous exercise? UN plus 2 will be x squared. 2UN minus 1 is, anybody? 2x, yeah. And minus 35 UN? 35, okay, equal to 0. You solve your two solutions, okay? So you do is x minus 7 and x plus 5 equals 0. And then all you say here is you go, look, x equals 7 and x equals minus 5. Now, do you notice the way it's not a repeated root? So the way it's not a repeated root, it's two different roots. What do you remember from the last exercise when it comes to that? Huh? Yeah, so I'll do L times my first solution is 7, isn't it? And then M times my second one, which is minus 5, yeah? There you go. That's my complementary solution, okay? So particular solution is minus 4, and this here is known as your complementary solution. Just make sure we spell complementary right. You all right with that? Okay. Next thing you're going to do is you're going to join them both together to create what's called the total solution. And your total solution is your comp plus your particular. Is that okay? So what do we think the total solution will be? Anybody? So L 7 power of n plus n minus 5 to the power of n, and then what we're going to slot at the end? Minus 4. Okay. Now it gives us two pieces of information at the start. Ready for two pieces of information? Okay. So the two pieces of information are U0 and U1. I'm going to grab the two of them and bring them downhill with me now. Okay, here we go. Now, I'm going to grab the two of them and bring them with me. Okay, I'm going to start off with U0. So U0, just replace everything with 0. Equals minus 1, right? And then I'm just going to end up with L plus M equals 3. All right? Then I'm going to do U1. And U1, this is the one that they used in the mocks, wasn't it? Yeah. Did anybody try it in the end, or you come out? Okay. And then it's L times 7 to the power of 1 plus M times minus 5 to the power of 1. Take away 4 equals 5. And I'm just going to get a 7L minus 5M equals 9. To save time, I'm not going to do the simultaneous equation. I'm just going to write down the answers. That's okay with you guys. L is 2 and M is 1. Is that all right? What do you think that does to our total solution? Which I'll now write in green. What do you think replace L with? 2, replace M with 1. And then just slot your 4 in behind and you're done. Okay. This one, this time, in the previous question, it would have been something like this, just equal to 3, and we would have said, look, let Tn equal A, because it's a constant on the other side. But what happens this time? It's not a constant, it's a, anybody? It's a linear, isn't it? So what we now say is Tn equals An plus B. All right. So what we're going to do is we're going to go through the whole thing, all right? But this time it's different because Tn is An plus B, but Tn plus 1 will be what? A n plus 1 times B, which is An plus A plus B. And what will Tn plus 2 be? A times n plus 2 times B, which is An plus 2A plus B. I'm going to go through the whole thing now, okay? This one, and this one. Okay, I'm going to sub them in now. So what we're going to get is An plus 2A plus B. That's for that one. The green one is going to be An plus A plus B. And then the blue one is going to be minus 12 times An plus B. So minus 12 times An plus B. Just going to multiply that out real quick, and I'm going to get minus 12 An minus 12B. And over the other side, that equals 3 minus 10n. Now, we're going to group these, okay? So here's what we're going to group. An minus 12An. So what are we thinking there? When we add them together? Minus 10An. But that will equal what's over the other side, which is? Minus 10n. So this informs us that A has to equal just 1, yeah? Okay, then we go for the next part. 2A, A. How many A's is that then? 3 A's, yeah? How many B's? Need a different color. B, 2B, 2B minus 12B, minus 10B. And the answer is 3, something that has no ends in it. Yeah? What do we think next goes? Put the 1 in, and you're going to find out that B is actually equal to 0. So we're on our particular solution now, okay? Our particular solution was this up the top right hand side. Ever see that particular solution? So what's our particular solution then? You want to tell me? Tn equals just An, isn't it? There's no B value. B value 0, yeah? Oh, sorry. You're right. because A is actually 1. So that's just Tn equals n. Okay. Now, what did we do last time for our, what's called the complementary solution? We pretended that the right-hand side was 0, and we solved it as a second order homogeneous. Okay, so what we're going to do with this full equation, x squared plus x take away 12, isn't it? Okay, so we'll do that now. X squared minus x take away 12 equal to 0. Two solutions to that, x equals 3 and x equals minus 4. See the way they're different? So what's that mean for the complementary solution? Remember, it's L and M, isn't it? So L times whichever one you want, and M times whichever one you want. So I think we'll go for L times, what's it? I'll just keep the same solutions. L times 3 to the power of n plus M times minus 4 to the power of n. Okay. Now I'm after what we call the total solution. What is the total solution again? It's your comp plus your part. Where's my part again? It's just n, isn't it? Complementary solution is n. And sorry, my particular solution is n. My complementary solution is up here. So what we're going to say? L times the power of n plus m times, or the power of n plus your part, which is just n. Okay. Now, you go back to the top of the board and you go T0 is 2, T1 equals 14, and now I'm going to have to insert it in and work it out. I'll start with T0. That n value will be 0 as well, won't it? That equals 2. So I should get L plus M equals 2. The next thing I'm going to do is going to do T1. T1 is, what are we talking about here? L times, what? Yeah, thanks. 3 to the power 1, 3, yeah. M times minus 4 to the power 1 plus n, which is just going to be plus, equals 14. And then we're just going to get 3L minus 4M equals 13. We are not going to do this out formally. Let's give you the answer. L is 3 and M is minus 1. And then our total solution becomes 3 times 3 to the power of n minus 1 by minus 4 to the power of n, and then just plus an n at the end. And we're done. That's her.